So today we talked about equations and how those work. We used a pan balance like this one to represent the fact that an equation has two sides on either side of the equal sign, and both sides need to have the same value. So if I were going to draw a pan balance here to represent this equation, it's an equation because it has an equal sign. One side would have 11 on it, and the other side would have 8 plus x. Now, x can be thought of it as a blank. That's the amount that we don't know yet. So I'm going to put 11 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to put 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8. And I need to figure out how many more I need to add onto there to get so that they're equal. Well, to make this side equal to this side, I just need to add 1, 2, 3. Now they both have 11. So x is equal to 3. You can think of the x as a blank. But it's just a placeholder, and you'll see a lot of letters from now on in math. Here's another equation. 7 equals 5 plus x. Now you could make another pan balance like this. Put 7 on one side. 1, 2, 3, 4, 5, 6, 7, and then put 5 on the other side. 1, 2, 3, 4, 5, and then add more lines and tick marks or tally marks until they're equal. If I add 2 more, they are equal, so x equals 2. But another way of thinking about this would be to say, what do I need to add to 5 to get 7? And that's what goes in there. 5 plus 2 is 7. And all the equations that you will ever have in math boils down to this. And you just simplify it until you get something like this that's really simple, and then you're able to figure out what goes in this blank here. So we'll do another one. Here's 13 equals 15 minus x. We could put 13 on one side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 15 on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and figure out how much I have to subtract so that these are equal. And I could just say, well, this has 5 here. I need to make this to a 3, so I can just, if I leave 3 behind, then I took away 2. Or you can just use mental math and say, how many do I have to subtract from 15 to get 13? Well, 15 minus 2 is 13. Or, what a lot of students noticed, you can just subtract 15 minus 13, and you'll get 2. So that's several ways of doing solving a simple equation like this one. Here's an equation that's a little bit more complicated. There's a little bit of math involved on this side. This looks pretty similar to what we saw in the last few problems, but here we have some work to do. So before we solve for x, we want to simplify all these numbers here. And I know we can because it's just a bunch of numbers, and we talked about expressions and simplifying those before. We can do that. Now we're going to use PEMDAS to make sure we do this in the right order. There's no parentheses and exponents, but we do have multiplication. So this multiplication goes first. So 2 times 3 is 6, and I'm going to copy everything else down. So I have 6 plus 5 equals 4 plus x. I can still simplify this further. I don't have any more multiplication or division, but I do have some addition. So I just add these. I have 11 equals 4 plus x. Now we're back to where we were before. And I can figure out what I need to add to 4 to get 11. And like we said before, you could just subtract them. And I get 7. So x is 7. 11 equals 4 plus 7. Here's another one that you need to simplify first. This one's a little trickier because what I saw some students do is just start simplifying this from left to right. They add 4 plus 2 is 6 times 5 equals 7 plus x. And they got 30 equals 7 plus x, and then x would be 23. That is wrong. That is absolutely wrong. We need to use PEMDAS. Okay? There's no parentheses, there's no exponents, but we do have some multiplication, and we have to do that first. It doesn't matter that this is at the end of the expression. We have to do it first because it's the proper order. 2 times 5 is 10, so we do that first. And then we copy everything else down. 4 plus 10 is 14, equals 7 plus x. Now we're at the simplest point before we solve for x. And I know that 14 is 7 plus 7, so x must equal 7. Or you can just do 14 minus 7 and get 7. That's another way of getting the solution to this problem. So here's kind of a multi-step problem from the book. It's not a word problem, it just gives us a couple of balances, and we have to figure out what the weight of one of these green cubes is. Now here I have one circle, and then I have some weights, and here I have 4 circles, and then I have 2 cubes. This first balance doesn't tell me anything because there's no values to any of these. I don't know how much one circle is. I don't know how much these cubes are. But this does give us some numbers. So I'm going to add these together. Why don't I call this this x, this one circle x. So x equals 5 plus 2. And 5 plus 2 is 7. So I know that one of these circles is 7. And since there's 4 of them, 7 times 4, so this whole thing here is 28. That's 7 times 4. Since this scale is balanced, that means this side has to be the same weight. Or, weight. So this must also be 28. Well, let's use another variable here. Let's say these 2 cubes are equal to y. Y equals, or 1 cube, excuse me, we're trying to find 1 cube. So we'll say one of these cubes is equal to y. So if I multiply 2 times y, I get 28, like this. So now we have a story problem here, and we're going to use the cubes method to solve it. So the first step of cubes is to circle all the numbers. We have 14 here and 5 here. So Casey placed 14 cubes on the right side of the pan balance. She places 5 cubes on the left side. She then removed half the cubes on the right side. Find the number of cubes that Casey must add to the left side to balance the pans. So I'm going to underline the question here, and then I'm going to box important words. So I would say, well, there's a right side of the pan, and then a left side, and right side again, and left side. And I'm going to say removed. That's important. That means subtract. And then half. That means 1/2. And add. So that's another math word. So now I'm going to just draw a picture of a balance, like this. Casey placed 14 cubes on the right side of a balance. So I'm going to say 14 cubes here. And then 5 cubes on the left side. So I'm going to put 5 here. Then she removed half of the cube. So what's half of on the right side? So what's half of 14? That would be 7. So I took half of that out, and I'm left with 7. So I have 7 on this side and 5 on this side. And so now I need to find the number of cubes that Casey must add to the left side to balance the pans. So I need to figure out how many I add to here to make them equal. So I'm gonna express this as an equation. 5 plus something, I'm going to call it x, equals 7. Well, now that I look at it this way, it's pretty simple. I just add 2. 5 plus 2 equals 7, so the answer to this would be 2 cubes.